Hello folks, I am your host Ali Raj and you are watching Gassightman. So now we have got a little conceptual overview of deep learning, very brief. The next question to answer is why would we want to use machine learning or deep learning? So the good reason is why not. I mean, you might have seen what machine learning is capable of. You might have heard of the power of deep learning, the power of artificial intelligence, and just all the problem we have got in the world. Why don't we just use it? Maybe, but a better reason is for a complex problem, such as maybe we are trying to teach a self-driving car to drive. Can you think of all the rules you would have to code if we remember back to our Silesian grandmother famous chicken recipe? Maybe you can code up the rules for that, such as preheat the oven, cut up the vegetables, cook the chicken for 30 minutes. But in terms of self-driving car, I mean, when you go for a drive, do you think about the rule in your head or do you just drive like I mean? You need stop signs, you need traffic lights, you need what to do for any other car. You can imagine how that problem gets quite out of hand pretty quickly. So for a very complex problem, can you think of all the rules? Probably not. And so I found this great comment on one of my YouTube videos here, the 2022 machine learning roadmap. So be sure to check that out. If you haven't checked it out, this is from Gassightman. I think you can use ML. So machine learning, if you see ML throughout this course, it's machine learning for literally anything as long as you can convert it into numbers and program it to find patterns. Literally, it could be anything, any input or output, or we have seen that again, input or output from the universe. Wow. Important piece to note here is as long as you can convert it into numbers. Now again, if you are reading this and you are like, Daniel, this doesn't make sense, I have never experienced deep learning before. Don't worry, we are going to have plenty of practice throughout this course. But here the exciting part, I think you can use ML for literally anything as long as you can convert it into numbers. I want you to keep the sentence in your head. However, when should you not use machine learning? If you can build a simple rule-based system, actually may not be a very simple. If you are building a complex software product that doesn't require machine learning, do that. Where this come from? Well, this is from a very wise software engineer. It's actually rule one of our Google machine learning handbooks. So this is our first external resource for the course. There is going to be a bunch of A+. So don't worry, I will link them to wherever you need them. So this is the rules of machine learning. Best practices for ML engineering. We are not going to go through this, but I am going to link to this. If you want to read through this in your own time, feel free to do so. This is very exhaustive resource to get you up to scratch on how Google thinks about using machine learning. So we will come back. So yeah, if you think about machine learning but you think you can code up a simple rule-based system, you should probably do the rule-based system rather than the machine learning. So what is deep learning good for? For problem with long list of rules. So when the traditional approach fails, machine learning / deep learning. Again, whenever you see throughout this course machine learning / deep learning, you can kind of think of them as the same thing, may have continuously changing environment. So if the problem you are trying to solve is constantly changing, I mean the information you are dealing with is continuously changing. The good thing about deep learning is that it can adapt to a new scenarios. So if the problem you are working on changes, you can train any other deep learning model on those changes. Discovering insights within large collection of data. So imagine the problem of trying to take photos of food and identify what is in that photo. Can you imagine trying to handicraft the rules for 101? So you just watch to start it, and with you building an app called 101 dishes. So you have got maybe a spaghetti, ramen, steak, egg, kale, coffee. Here imagine trying to handicraft the rules for 101 different kinds of food. Look like I can't. Now what is deep learning? not good for. Typically, again, take this with a grain of salt, because as you will see, as you get deeper into your pond, the pond deeper into your deep learning journey, you will see there are a lot of way if you are stuck on a certain kind of problem. About what we are going to see on this slide, you can kind of formulate ways to circumvent that problem. When you need explanation to that pattern learned by the deep learning model, again, we have not seen these, or you will get familiar with them, or typically uninterpretable by human stuff. A deep learning model is finding lots of patterns in numbers, which we will see throughout this course. Typically, those patterns are quite hard to interpret once you look at them, when the traditional approach is a better option. Remember, if you can accomplish what you need with a simple rule-based system, you should probably do that. When errors are unexpectable, so since the output of a deep learning model are not always predictable, meaning they may contain errors, maybe deep learning is not your best option. If you need a software system to do the same thing every single time, potentially a non-deep learning based system is what you are after. And when you don't have much data, so deep learning model usually require a fairly large amount of data to produce great results. However, we will see how to get great results without huge amount of data. So as I said, typically not good for. There are ways to kind of try any circumvent these point here. So let's have a look again, machine learning versus deep learning. So in terms of when to use machine learning versus deep learning, traditional machine learning algorithms have typically performed best on structured data. So what I mean by structured data is a data or information you can find in an Excel spreadsheet or a Google sheet. So you have got rows and you have got columns. So this is clearly row 2. For example, we have got car sales, we have got to make, we have got a color, we have got a domino dot, or we have got a fry. So maybe we want to build a deep learning model or a machine learning model to take these parameters here. We are often referred to as feature. So column features make color a dominant dot and predict the price, whereas deep learning typically performs better on unstructured data. Such natural language test, the case we want to build the food 101 application to take the photo of food and identify what is in that food, or if we have a Wikipedia article talking about deep learning. So this is an example of data that you could that there is a structure to this picture. Like, I mean, you got a shape here, you got shape there in here, you have got a sentence there, but it's certainly nowhere near as structure as what you find in an Excel spreadsheet. And then again, you could have something like voice. So sound waves go here. We will dig a little deeper into the structured versus unstructured data. Let's have a look at some of the most common algorithms you are going to come across, and then machine learning and deep learning world of course. This slide only goes through just the names of the algorithm, but we are going to be getting hands-on with the building some of the most common deep learning algorithms you see coming up in a minute. So in the machine learning side of the things, you might have the random forest, the naive Bayes, nearest neighbor, sport vector machine, and many more. And since the advent of deep learning, these algorithms here are often referred to as a shallow algorithm. Now what that means for now is not too important. I just want you to get stuck getting familiar with some of the terms you are going to hear in the machine learning and deep learning world. So when they come up, you are not going to know what does that mean. Now on the deep learning side of things, we have neural networks, fully connected neural networks, convolutional neural networks, recurrent neural networks, and the transformer architecture is fairly new one that's only come out in the last couple of years. And for this course, we are going to be focused on building these 4 types of neural networks here with TensorFlow. These are kind of like the bedrock type neural networks, the ones that are deep learning field over the past decade, also has been built on the top of. And again, if we are looking at through the structured data versus unstructured data paradigm, these algorithms here, the machine learning algorithms, are typically better performing unstructured data, whereas neural network type architectures are typically better performing on the unstructured data. However, depending on how you present your problem, many algorithms can be used for both structured data and unstructured data. Now we have covered the names of a few types of different neural networks architectures. So you are probably wondering, or the question in your head is really, what exactly are neural networks? So let's tackle that in the next video. See you. Bye. गेट साइटमेंट को लाइक करें, चैनल को सब्सक्राइब करें और बेल आइकन को दबा दें ताकि इस जैसी अपडेट्स आपको मिलती रहें।